So hello friends, today we are going to discuss about a special process that is called as a reversible process, which is also termed as mechanical reversible process. Whenever a process is taking place, a thermodynamic process where the states are changing, it could be either a reversible process or an irreversible process. Irreversible process takes place at once, where the changes are sudden and abrupt. Whereas reversible processes are the processes where the changes are infinitely slow. Because of that, the succession of path is such that at every given time the system is at equilibrium. And because of that, what happens is that you can just reverse the direction and can take the system back in the original equilibrium state. So hence the definition of a reversible process is that a process is reversible when its direction can be reversed at any point by an infinitesimal change in external condition. So consider this piston cylinder arrangement where a gas is confined in a cylinder, and this is in equilibrium with a piston which is having some mass m on top of it. Now see, we can abruptly remove this entire mass m from the piston. Because of that, what will happen? Piston will move upwards because the equilibrium is imbalanced, and piston will be pushed upward by the gas, and the piston will move in the upward direction. It will oscillate and will come to a new equilibrium state after some time. During that, it will be having some kind of resistance due to the friction. That is one. Two, it will oscillate and it will lose its energy, and the new equilibrium state which it will be achieved will be which will not be exactly as we wish if we remove the mass one by one. So that is the process would be in a way an inefficient process if I abruptly remove the mass. Another aspect is if I keep entire mass back at the new equilibrium state, because in between the process it has lost some kind of energy, it will not be able to come back to its original or the initial equilibrium state. As against that, if I change the method of removal of mass m, what I do is I convert the entire mass into small pieces as has been shown in the figure, and I remove, like if I have kind of an imaginary arrangement of keeping some trays over here, wherein I remove one block from this and shift it to this tray. So there is a very less difference in the equilibrium. So piston will move slightly upward and it will not oscillate, it will just move upward. Then once it comes back to the comes to the equilibrium state, I remove the another block and put it here. So this will move again in the upward direction, but it will not oscillate. So every time I remove a small mass of m, piston slowly moves upward. That is what we mean by infinitesimal changes. If I take this back, the piston will come back to its condition. Take this back, come to its original state. So likewise, I can reverse the direction by just changing the way I was removing the mass. Now I am putting back the mass. So changing the direction, I can take the condition back to its original condition. So that is called as a reversible process, and this is the most efficient process for the given state change. Let us try to understand some other characteristics of this. So this is something which I discussed. If we remove it in two different ways, one by removing it a stretch or by removing it in piece by piece. So this process is irreversible and this is reversible process, right? Reversible processes are the most efficient process, or you can say they are the reference process, and you can compare your irreversible process with respect to efficiency with comparing the efficiency with respect to reversible processes. Let us try to understand, let us try to see some of the characteristics. Before that, what do you think about the change in pressure of the gas? So how it happens, when you take it at a stretch, what happens is that the piston has to work against a continuous pressure of the atmosphere. But if you remove it one by one, the pressure is continuously changing. So this is the basic difference, that when you remove it at a mass at a stretch, right, the gas is working against a fixed pressure, which is atmospheric pressure, whereas if you remove it one by one, the gas has to work against series of pressures, which is decreasing. So a reversible process will be working against a decreasing pressure. So other characteristics of reversible processes are, it is a frictionless, as I already told you. It is never differentially removed from equilibrium. This also we discussed. It traverses a succession of equilibrium state. As I mentioned, at every stage it will form a new equilibrium state, and it can come back to its original state by just reversing the direction, right? It's driven by forces whose imbalance is differential in magnitude. Again, the same thing which we discussed. It can be reversed at any point by differential change in the external condition, just reversing the direction. When reversed, it retracts its forward path and restores the initial state of the system and surrounding. That means, this is very interesting thing. It follows the same path back, which is not possible in irreversible case. In irreversible case, because of the oscillations and the loss of energy, even if you put that entire block of M back, piston will not follow the same path, and it will not end up in the same initial state. So there will be a change in the energy. For a mechanically reversible process, the work related to expansion and compression can be given by this. Now when this is a reversible process, since the pressure continuously changes, you cannot take it outside the integral term. But if it is an irreversible process, right, the pressure against which the gas has to work is fixed, because I am removing mass M suddenly, and then the pressure remains fixed, and hence I can take this term outside this. So that is the major difference. Any mechanical reversible process, the work is to be obtained by integral P dV, where P is a variable. Whereas for an irreversible process, your work can be done as minus P into integral dV, which can be then written as minus P delta V. So that is the basic difference, and because of this, there is a change in efficiency. The work, suppose if I want to make a change in a system by adding work, the work required for a reversible process will be the least. But if the system is generating work, the work obtained from the system by a reversible process will be the highest. And that's why a reversible process will always give you a reference. As I told earlier, the reversible process will give you the maximum amount of work when it is to be obtained from the system, and it requires minimum amount of work when it is to be done on the system. So these reversible processes are the form of ideal processes, and we'll see in as we proceed further in some other videos that how can we compare two processes with respect to their irreversibility. Thank you.